Okay, there's two tests we're going to learn in this chapter that help us find extrema. Both are called derivative tests. This is the first derivative test. Okay, it says let f be continuous. It's got to be continuous over an interval, and where c is the only critical number. If f is differentiable on the interval, except possibly at c, then f of c can be identified as a relative minimum, a relative maximum, or neither, as shown below. So basically, here's what you do. If you find a critical number, if the derivative is negative to the left of the critical number and positive to the right of the critical number, then f of c must be a relative minimum. Now, that's this one here. So down here, you see, we'd have a critical number here because here's where the derivative would be 0. If you tested to the left, you would find that the derivative is negative, and I can tell that because the function is decreasing. So the derivative would be negative on this side, the derivative would be positive on this side, and so by the first derivative test I know that I get a relative minimum at this point. The second one says if the derivative is positive to the left of the critical number and then negative to the right of the critical number, then f of c, the y value, would be a relative max. So now let's take a look at this one. Here we get a critical number because the derivative would be undefined at that sharp corner. But if you look to the left, see the function is increasing, so I know the derivative would be positive on this side, and then over here, since it's decreasing, the derivative would be negative on this side. So therefore, by number 2, this point would be a relative maximum. Now, there's a couple of cases. If the derivative is negative on both sides of the critical number or positive on both sides of the critical number, then you don't get a relative minimum or max. So let's take a look at this. This point right here would be a critical number because you get a vertical tangent line here. But to the left of this, the derivative would be negative, and to the right of this, the derivative would be negative, because the function is decreasing on both sides of it. So since the derivative is negative on both sides, you do not get a relative extrema at this number. Over here, this one's a critical number because here you get a horizontal tangent line, so the derivative is 0. But to the left of it, immediately to the left of it, the derivative would be positive, and immediately to the right of it, the derivative would still be positive. So therefore, you don't get an extrema in that case. So here's how we do extrema. It's a little bit, it's pretty much the same way we did the test for increasing, decreasing, except now we can determine extrema. So basically we find the critical number. So if we have this function, we get the derivative, and then we find the critical numbers of the derivative. You already know how to do that. So negative 2. And then we break the number line up like I did before. Break the number line up at negative 2, and then, or the number line being the x-axis. Okay, so then I look at what's happening to the left of this critical number. This vertical line represents negative 2. So let's look directly to the left of negative 2. So I'm going to test negative 3. So at negative 3, the derivative is negative. Okay? Now let's look directly to the right of negative 2. 0. So if I plug 0 in, I get a positive number. So the derivative is positive. Okay, so since the derivative is negative to the left of negative 2 and positive to the right of negative 2, then that means I get a relative minimum at negative 2. And the minimum is the y value. So to get the minimum, I have to plug negative 2 back into the original function up here. So negative 2 plus 2 is 0, and 0 squared is 0. So f of negative 2 is 0. So basically, this graph has a minimum at the point negative 2, 0. Negative 2 is where it occurs. 0 is the actual minimum. Okay? Next one. All right. I'm going to bypass some of this algebra because we've already done these. I'm just recycling the same functions. So starting with 3x cubed minus 18x squared, we know that the derivative is 9x times x minus 4. These are the critical numbers. So basically, you know, I'm just breaking the graph up into the intervals like we did before. Okay, so this is 0, this is 0, this is 4. Okay, so let's consider 0. Just to the left of 0, if I plug -1 in, I'll find that the derivative is positive. But if I pick a number just to the right of 0, like 1, I find the derivative is negative. So since the derivative is positive to the left and negative to the right, then I must be getting a relative maximum at 0. So f of 0, which actually is 0, if you plug 0 into the function you get 0, f of 0, which is 0, is the relative maximum, and it occurs at 0. So the point 0, 0 is a relative maximum, where 0 is x equals 0 is where it occurs, and y equals 0 is the actual maximum. And then at 4, if I pick a number to the left of 4, which I've already done, 1, I get the derivative is negative, and to the right of 4, I get that the derivative is positive. So since the derivative is negative to the left of 4 and positive to the right of 4, then 4 must be a relative minimum. So I get a relative minimum of f of 4, and to get f of 4 I had to plug 4 back into this function up here. So I had to figure out, you know, what is 3 times 4 cubed minus 18 times 4 squared, and I got -96. So the minimum is -96, and it occurs at x equals 4. Alright, here's another one, x squared minus 4 to the 2/3. Okay, so when we take the derivative and find the critical numbers, we found 3 critical numbers, 0, -2, and 2. So this vertical line represents -2, this vertical line represents 0, and this vertical line represents 2. So to the left of -2, if you test a number left of -2, you find that the derivative is negative. If you test a number to the right of -2, you find that the derivative is positive. Well, since the derivative is negative to the left of the critical number -2 and positive to the right, then we get a relative minimum at -2. Okay? And if you want to know what that minimum is, go back up in here, plug -2 into this, and you'll get 4 minus 4 is 0 raised to the 2/3, which is 0. So we get a minimum of -2, 0. -2 is where it occurs, 0 is the minimum. Relative minimum, actually. Alright, now at 0, to the left of 0, the derivative is positive. And when I plugged a number to the right of 0 in, just to the right of 0, I got the derivative was negative. So the derivative is positive to the left of 0, negative to the right of 0. So f of 0 must be a relative max. Okay? Now, the way I got the y value, the 2 cube root of 2, I actually had to plug 0 in here. It's a little complicated, but it's not too terrible. If you plug 0 in here, you get -4 to the 2/3 power. So what that means is you're taking the cube root of -4 squared. So basically you're getting the cube root of 16. And then I just simplified that radical. The cube root of 16, the cube root of 8 is 2, so I can say take the cube root of 8 out and get 2 times the cube root of 2. So you can, that's just some algebra. Alright, so those 3 points are your extrema. -2, 0, 2, 0 are relative min points, and 0, 2, cube root of 2 is a relative max point. Okay, here's another one. This one, when we found the derivative of this function, we got minus x minus 1, x plus 1 over x squared plus 1 quantity squared, and we found that x equal 1, -1 were critical numbers. So this line represents -1, and this line represents +1, and so to the left of -1, the derivative is negative. Just to the right of -1, the derivative is positive, and just to the right of +1, the derivative is negative. So let's look at -1. At -1, the derivative is negative to the left, positive to the right, so we must get a relative minimum. And the minimum is whatever f of -1 is. And so just plug -1 in here, and you get negative 1 over 2, which is negative 1/2. And then here at 1, the derivative is positive to the left and negative to the right, so you get a relative maximum of f of 1, and if you plug positive 1 in, you'll get positive 1/2. So that's those are the critical numbers and the extrema. That's the extrema for that function. Okay, just a couple more. Remember this function, we actually got this as the derivative, but remember the domain of this function only went from -2 to 2. So we could only look at what's happening between -2 and 0 and 0 and 2. So if we look at to the left of 0, the derivative is positive, and if we check to the right of 0, the derivative is negative. So at 0, I get a relative max. So if you think about that, if you remember this, it looked something like this. It was a semicircle, and so the relative max is up here at I think it's the point 0,2. So the point 0,2 is the relative max. But actually, this point here, since it's an endpoint, is technically a relative minimum because it's the minimum value in its neighborhood, and this point here is a minimum. But you can't tell that by checking each side because there's nothing to the right of 2 and there's nothing to the left of -2. So, but if you look at the graph, you can see that f of -2, which is 0, is a relative minimum, and f of 2, which is 0, is also a relative minimum. Okay, the next one, remember, its domain was x must be greater than or equal to -1. So the domain is -1 to 0. And the critical numbers were -2/3 and -1. So remember, I had to stop here at -1 and then, go on out. And then I break it at -2/3 here. Okay, now to the left of -2/3, when I checked the derivative, I got negative. To the right of -2/3, I got positive. So at -2/3, I actually get a relative minimum. And you'll have to plug -2/3 into the function to see how I got this value, -2 square root of 3 over 9. So anyway, and then also, remember this kind of looked like this. It started here and then it kind of went down and went up. Well, this point here at -1, it's a relative maximum because it's the largest value in its neighborhood. Okay, so points like that you can't determine using the first derivative test. You just have to determine it from the graph. Okay, take a look at number 7. Freeze the video if you have to, and then work through it and see if you can identify the relative minimum and relative maximum for that one. Now, there's a few practice problems here that you can do. So do these practice problems and check the answers, and send me a note if for some reason I got the answers wrong. I'm pretty sure I double checked them with the graph, but notice that C and D. Notice that C and D are similar, but C is to the 2/3 power is actually going to have a minimum and it's going to have a relative minimum, but not a relative maximum. But D is going to have neither a relative minimum nor a relative maximum. Now you will get a critical number, but you won't get a relative extrema. So you can do those as practice and then check your answers. Now I do have to finish up one more topic on this section, and I'll do that in the next video where I talk about absolute extrema. Remember, I warned you we were going to get to that.